Albi from Matter Labs. I'm a Devrel engineer, and today I'm going to talk about account abstraction, kind of walking you through the story. How did it go? How did it started the actual implementation into different networks? What happened there? How long did it took? And then we'll dive into the actual implementations and see one example when it comes to different type of signature on the for one of the smart contracts, smart accounts that we'll develop. So yeah, let's get started. This is me. You can follow me on Albi Codes on socials, and also if you are interested for zkSync development, you can follow us on zkSync Devs account on Twitter. What's the progress to onboard 1 billion users on chain? What's happening on this regard? Because last year during ETH Denver in 2023, all of the presentations that were there were like, oh, account abstraction, we are onboarding the next 1 million users, we are onboarding the next 1,000 users, or I don't know what, right? So it was, the problem was, oh, we are onboarding people more, and how we are doing that, basically the technology was just published during those days at ETH Denver. So let's see how we are kind of dealing with that. To be able to onboard those 1 billion users, they need to basically get to create an externally owned account and get started, right? But for these 1 billion users who are non-technical and normal people all around the world, they need to go through some steps to create this externally owned account, and we'll review them, all of us together now, since maybe we have passed this initial step very early on, and we forgot how hard it is for normal people to get to create their wallets or their accounts. So first things first, they need to go and find an application that will offer them the chance for them to create a wallet, right? Something secure from an app store or something. And then on that application, they need to create a wallet. The next step would be, on the creation of the wallet, they need to save this seed phrase of 24 words in a vault in their garage or somewhere in their house, so that they will be able to access it or save the funds and not lose any kind of access to the account. After it, they will need to verify the address that they are creating, and then for them to be able to get money on their account, they need to share this address with someone or somewhere so that they can receive the money on that account. They will receive the USDC, and now they are ready, let's say, to go and interact on chain, right? Well, not really. They need ETH to pay for fees on Uniswap when they want to kind of swap their tokens. What can they do after that? They can go and get their money from their bank account to a ramp to fund the gas. Get that money, put it on their wallet again, buy ETH with those money so that they can fund the swap on Uniswap. Go back and then send it to the account that they created, and then go back again on Uniswap. Now that they have some ETH to fund the swap, they can do it there, right? And yeah, well, now it's time for them to buy something on OpenSea. They go to OpenSea, and they're like, oh, I have some ETH, I have some USDC as well, maybe I'll just buy something there, right? But no, because OpenSea needs a wrap ETH, so they need to go back, get some wrap ETH, but first, before doing that, let's just rest for like 2 or 3 days or maybe a week, because why do I fucking need that thing, right? So I'll just not do that anymore. But no, maybe we are patient. We are like, let's take it slow because maybe we'll make it happen, right? So they go back. They go back to Uniswap. They wrap their ETH, and then they go back to OpenSea. And then they see that, oh, but I did all of my ETH into wrap ETH, so now I don't have ETH to actually fund the transaction whatsoever. Here's a 15-minute step. And this is us, all the time, when we have to interact with the actual on-chain world. And it's exhausted. this is me. Like, I remember myself for the first time when I received USDC, and I went through that process, and by the 13th step, I had to sit down with a friend to be like, please help me, because this feels too risky for all of my, like, I received 1,000 USDC in my wallet. I was like so scared to even touch it, right? So whatever, let's just move forward. I know that this topic is like, compared to Elena's quantum computers, is not that exciting, but just stay with me, okay? So what are Ethereum accounts? We do have two different Ethereum accounts, externally owned accounts that we just saw the process from a user's perspective, what it is for them to actually get on chain. But on this slide, we will talk more about the technicalities of these two accounts. So to create an EOA, it's costless. So you don't have to pay anything. You can create an account, and then you're able to do transactions and do them on ETH or in any other ERC20 token, right? What's the one thing on the security perspective for externally owned accounts is that they rely on the pair of cryptographic keys, such as public and private key. And then on the other aspect of the smart accounts, compared to the externally owned accounts, they do cost. To create a smart account, you will need to pay some money for you to be able to create it because it uses network storage. So when it comes to transactions, they do respond to externally owned accounts transactions toward the smart accounts, and then they can automatically react with whatever customizable code that we have done on the account, right? And then there is no keys for you to save, there is no keys for you to manage when it comes to the accessibility of the account. You can actually just access it via different functionalities that you have done through code. What are the limitations of the externally owned accounts is that this security layer that kind of relies on the pair of cryptographic keys is that you need to have that private and public key, right? And when you think of the traditional bank account, you have your username and your password. So in this case, when it comes to the password or the private key, will give you access to your account and you're able to access your assets, digital assets, right? What does that mean is that it's just one password. How many passwords did we lost or like we forget or we just don't care anymore? That's it. That's the key security layer for your externally owned account for whatever like use case that you would do. If you lose your key, you lose your funds and your account gets compromised. So that's one key point where you're like, that's it, right? So what about the functionalities, limited functionalities, as I repeated earlier, is that you're able to do transactions in ETH and other ETH ERC20 tokens, but to who and what not is only that you can kind of send those transactions to a smart contract account. And that's it, right? Maybe just to trigger some specific functionalities on those other accounts. Very limited. UX, yes, we saw how that goes when it comes to 15-step process. And then the economic limitations. Imagine a world where those 1 billion users join and all of them have to every time sign a couple of times to do a single transaction, right? That takes a lot of time. And in terms of millions of transactions, let's say, in different use cases, well, say goodbye to that for the next 3 years maybe, or we don't know. So yeah. The history of account abstraction development, it started in 2015-16 with different EIPs, such as the 86, which tried to eliminate the address, pre-configuration of the address, and kind of control those contract accounts in a more manageable way, which didn't go through actually, and then it continued to EIP 101, which tried to differentiate the transaction and the execution flows. And this was also like, had challenges when it comes to the actual protocol implementations. And I've integrated the zkSync development when it comes to the actual journey of the account abstraction implementation, zkSync 1.0 came late 2019, which offered simple normal transactions and ERC20 tokens as well on ETH and those. And then after it, EIP 2938 came up, where it kind of settled the base work for later on the other EIP that is very famous that actually supports the account abstraction. zkSync 2.0 came up, which offered the zk first EVM to extend the Ethereum's functionality for scalability and also development on top, on the layer 2. And then the team introduced the design of account abstraction on the protocol layer level in 2021. And then fast forward to 2023, EIP 4337 came up from Ethereum core developers, and together with the zkSync, going on mainnet with the native account abstraction implementation. So this happened like a year and a half ago, right? During ETH Denver last year. And from that time, what else do we have here? What do the account abstraction what does the account abstraction enable us to do, right? It offers us ways where we can actually recover our account with a social layer of friends where to whom we trust, and we don't have to rely on our keys, we don't have to rely on our passwords. We can connect a couple of personas together so that we can, every time we would lose access to it, we can use those resources to actually be able to get back to the resources. And then we can set up spending rules based on the limitations and also destinations. If it would be like you do some type of interaction swap functionalities in a specific time of day, you can actually do it in an automatic way. And then when it comes to monthly subscription type of payments, you can also set that up with the spending rules that you can do in your smart account. Flexible validation, which is something that I will connect again the dots by the end of the presentation, is that you will be able to set up those different ways of signing up with your wallets, because now with the account abstraction, it will allow us to play around with the signature part. So it's not anymore like just a specific structure. You are free to actually develop a customized way for you to be able to accept any type of signature from your to your account. Multi-call and sessions as well, where you would be able to, gaming, for example, get to sign in once, so that for the next specific time you are a gamer can be able to play without any interruption, and every transaction can happen synchronously themselves, and it can be controllable by different limitations that you can put in. And then of course the paymasters, which enables the multi-token gas payment or even gasless payments when it comes to those use cases. Those are the features that account abstraction enables us to do, right? But then when it comes to different implementations, I mentioned that the EIP 4337 came up from Ethereum Foundation or core developers, but it introduces a new transaction flow, which has its advantages and also disadvantages, right? There is the user ops mempool, which collects all of the user operations in one place, and then the bundlers are the personas where they can collect the user operations and push them to the actual on-chain changes. The paymaster is not like an enabled feature for externally owned accounts. It is only for smart contract accounts when it comes to this EIP. Whereas when it comes to our implementation at zkSync, everything is in one transaction flow. Since the account abstraction feature is implemented on the protocol level, that means that every externally owned account is a smart account, because on the protocol layer, we have implemented this contract that is called default account, which has the infrastructure in place so that if this account is not set up with parameters to be used as a smart account. It can just continue to do normal things as an externally owned account. But if it's programmable, then it will just continue with the other coding functionalities that we have done. Of course, this implementation was inspired by the 4337 because from the history of the pipeline that I shared that the actual account abstraction work started in 2015-16. So our team actually had a lot of resources from where they can learn and kind of get the best from both worlds. In here we have the operator in our protocol, which acts as a bundler that collects all of the transactions coming from two different accounts, types of accounts. And then we have the bootloader that acts as an entry point that collects all of these and sends them to the blockchain. The difference or the advantage in this native account implementation is that you can have a paymaster with just a parameter check on your transaction parameters, right? And you can create a paymaster functionality on top of your externally owned account if you don't want to have all of the other benefits that I mentioned, such as the account abstraction or like the spending limits or stuff like that. You just want to have payments of gas in whatever token, then you can do just that. Where can you see? Like since a year and a half from 2023, March, you can actually go right now and check those decentralized apps that are on zkSync. All of these use account abstraction on their application. All of these use paymasters as well. Their users are able to pay gas in different tokens or even have gasless fees. So just for you to be aware and be like, hey, but what can I do on zkSync? You can actually test some of these apps right there. They are in totally different categories. Some of them are DeFi, creator economy, someone via wallets, and gaming as well. Now, when it comes to the account abstraction implementation and how you can do your own project, we offer different interfaces. One of them is the account interface, and the other is Paymaster interface, which you will be using it as a base for your code implementation. The account interface is called by the bootloader that we mentioned earlier and validates all the transactions that come in this part. Use cases that I mentioned a little earlier are here, but on a more technical context layer, we can have different validating signatures for transactions and actions based on those signature validation processes, right? And one of the use cases that I'll share now, it's connected to the validation of the signature. And then we can have multiple signatures from different parties as multi-sig account, and then also authenticating users within smart contract interactions, authentication or identity side. I think that's not, okay. So this is the interface. It has like 5 different functions. The first function is validate transaction, which is very important because that's where transaction starts, and then that's where it gets validated if it will continue or not, or it will revert. We have execute transaction, which gets, after the validation, it gets the transaction and sends it to fruition. We have pay for transaction. In this case, if the transaction doesn't have the paymaster parameter, then it will just know that this account is responsible to pay any transaction fees. And then prepare for paymaster is optional, meaning if it doesn't have a paymaster, then just ignore it. If not, continue with the paymaster paying the fees. And the execute transaction from the outside, which executes transactions from, let's say, externally owned accounts that I mentioned earlier to trigger different functionalities within a smart contract. The validate transaction here is a function that the implementation of it can take different forms, right? So in this function inside, what we do from the start of the contract, of the function, is that we increment the nonce for that transaction if it's gonna be successful or not. If we validate the transaction hash, We check the balance, if we have the money or not to pay for that transaction fee, and then we handle the signature, the signer type. And what is the signer type? The reason why I put a cooker emoji there is that this is an actual use case that we are currently seeing it now. This is not something that comes with the base functionality of iAccount, but something that I just did. This examines the first byte of the signature to determine the signer type between hot and cold wallet. We want to restrict the hot wallet to a specific kind of restriction if we see that that transaction is coming from there. And if it comes from a cold wallet, we just want to let it go. Whatever transaction comes, it comes. But how did we do this actual signature change, right? How do we know that the first byte of the signature determines the signer type? Because this is the actual feature that we implemented in the digital signature part, and we'll see it now. To get into that topic, I want to give an introduction to the ECDSA signature, which is elliptic curve, a digital signature algorithm, which is used for externally owned accounts to create the digital signature and to verify its message and authenticity. It's a cryptographic algorithm, and it uses the curve that is called SEC-P256K1, and it's known for efficiency and its security. The ECDSA signature has a format, and it usually consists of two different integers, R and S, which are derived from the elliptic curve operations. And we have in Ethereum the additional value V, which stands for the recovery ID, and it reconstructs the public key based on the signature that is generated. This type of digital signature is used for externally owned accounts. So whenever we want to sign a transaction, that's where it gets created, right? And then when it comes to smart accounts, I'll just talk after this. This is kind of a diagram for you to be aware of what happens on this digital signature signing part. The user starts, they want to sign something, and they will have to connect with their wallet and sign with the wallet. Creating the transaction data, then we hash the ECDSA signature, hashes the transaction data, goes back the hash data with a private key. We send the hash data and the private key again, and then the ECDSA gets back the digital signature that includes this hash data together with the private key. And after it, we're able to send the transaction data together with the digital signature to the blockchain because it's already verified and accepted. But when it comes to signing digital signatures from the smart accounts, right, what happens then? So there is different standards. There is different signature standards for you to be able to use them from scratch. For example, this ECDSA signature algorithm, it exists. There are different formats, functions for you to use, etc., right? But in this case, for us, that we want to change the signature of our smart account that we are building, for that signature to have the first byte to be 0, so that then we can add other restrictions. We use the EIP 1271, which is verification format for smart accounts. It's a standard for verifying signatures on behalf of smart contracts, not users, right? Not EOAs. Ensures interoperability and security between different apps. And use cases. This is the same as earlier that I mentioned, to validate signatures for transactions and actions initiated by the contract. This is the function. It passes the hash and the signature that we checked on the other slide with the diagrams, the hash of the data assigned, and then the signature to be verified, and returns this actual value, which is static, to make sure that it's correct. This is our function. our customized function. Like inside of it, what we did is a little customized, but this is usually what is called is valid signature function. What do we do here differently? Usually the signature length is 65. We have added one more byte because we know that we want to allocate the first byte for our signature check. We want to have the first byte to tell us what kind of signer did we got this transaction from. Did we got it from the hot wallet signer or the cold wallet signer? So what we do here, we just go, we get, and we say, hey, we'll get the correct signature in this use case is gonna be 66 for the length, and then we are checking the valid ECDSA signature format because we remember from the last time that when we introduced the format of the ECDSA, it has 3 different values, right? The S, R, V, and then we call that other function that checks the format, returns true if it's good, returns false if it's not. And then this is the second part of this function. So we are just continuing to allocate the specific bytes for the location that we are having in the signature. We return the recovered address based on that recover method that is predefined. And then we check with the if statement if the actual first byte of the signature is 0. If it's not, that's where we will kind of assign the hot wallet and the cold wallet to different results. And that's it. In a way, we just did, and then this format check, which is the ECDSA's format, signature format, we go in here as well, and we do the same thing. We give it the length that it has. We say that we jump 33 bytes for that specific format and for the R, S, and V values. And what else does it have differently here that is very important? Nothing else other than those values that we are allocating for each parameter in the ECDSA formatting check. So we are checking the length, the values for RS and V within the expected ranges. So it's just the positioning, right? Yes. And that's it. I didn't include the other part of the code, which is the interaction script for me to be able to go create an account and go send a transaction, and that transaction would come from this account that it's a hot wallet and is not able to send more than 1 ETH a day and blah, blah, blah. So I just added this part of the code that actually changes the signature, and I wanted to kind of maybe as a takeaway for the audience, no matter how technical or not you are, if you are very technical, don't judge me, please, to go away with the 2 different signature types for the externally owned account that are handled by ECDSA, and then the smart wallets are handled by EIP 1271 that has different formats, right? And those different formats allow us to do customized signature use cases for smart wallets, and that is just one use case that we can play around with the signature, right? So yes, if you are interested to build on zkSync, feel free to DM me or follow me on zkSync devs. And here you have my email as well. So yeah, let's connect, and thank you for listening.
Thank you so much. Oh my gosh, I'm excited. That was cool. Who's still with us? Still with us? It's very, woo! Okay, use your fan if you're not. Okay, so that wraps up the workshop and the educational side of things. And now my favorite part of the evening, drinking? No, networking. So we are going to enjoy some food at the back. Then we're having an acoustic guitar session by Dami Das. Dami Das? Dami, say hi. Hi. Acoustic guitar sessions happening here with food. Then we're moving upstairs for an exclusive cocktail evening. 6 till 9, it will be unlimited cocktails. The bar is gorgeous. It's gorgeous. So thank you so much. Big thank to zkSync. Follow us on Twitter, Crypto Girls Club. We'll be doing more events. We're in Texas next week. We're at a pool party. So if you're at Consensus, come to our event. Thank you for joining and enjoy the Spatey. Bye.